Hey guys, today we're going to be looking at using the conversion we learned yesterday, which is converting between substances using stoichiometry. We're going to combine that with the other conversions that we were working on before fall break. And those conversions are written up here on the top of these notes, which are probably in your digital notebook. If they're not, they're attached to an assignment in Google Classroom. So pull them out and go through these with me. So we'll briefly go once again over the three conversions we have learned. The first one we learned was with Avogadro's number. Avogadro's number says that there are 6.02 times 10 to the 23rd molecules or atoms, those are particles, in 1 mole of a substance. So you can use Avogadro's number to switch between particles and moles. The next conversion we learned was going from moles to grams using the molar mass of a substance. That was where you took all of the elements in a compound and wrote out how many of each element there were, found the atomic mass, multiplied those together, added it all up to get a total. That was the molar mass. And the molar mass said that 1 mole of a substance equals the molar mass in grams. So you had to use the molar mass chart for that one. And then yesterday we learned a new conversion that goes moles to moles, so it keeps the same unit, but it switches the substance. And we used the coefficients, which are the big numbers in front of the compounds, in chemical equations. Today we're going to start working with all three of these together to combine the conversions. Let's look at number 1 here. It asks how many molecules are in 29.34 grams of water. We're going to approach this the exact same way that we've been approaching these problems forever, okay? We're going to take our chart, draw it if it's not there, which it is on these notes, but on other questions you'll have to draw it yourself. You draw the chart, then you take your given information. Your given information here is 29.34 grams of water. And you plop that information right here in the upper left-hand corner. I'm actually going to erase that so I have room to write. Okay. So we've got 29.34 grams of water, which is H2O. And we're going to have to convert that to molecules, going grams to molecules. Now, this is a conversion that we have done before last time we were combining conversions, going grams to molecules. So there's 2 things that we need to know, 2 conversions, and they're already written down here for you. The first one is that 1 mole of water has 6.02 times 10 to the 23rd molecules. That comes from Avogadro's number. And we also know that 1 mole of water is 18.015 grams of water, which you could find if you calculated the molar mass. You would say there's 2 hydrogens there, 1 oxygen. Hydrogen's 1.008 grams. Oxygen's 15.999. Multiply to get, that's 2.016 and 15.999, both in grams. If you add that up, you'll get 18.015 grams, this thing over here on this bottom conversion factor. And the third conversion we're not going to use here because we're going from grams to molecules of the same substance, and we don't have a chemical equation to work with. So we're not going to be doing the substance switch for this question specifically. All right, now we've got to plug these conversion factors up into the chart. So the way you have to do this is the same way we've been doing these things forever. We're starting with the unit grams of water, H2O, grams of H2O. So whatever's on top goes on bottom next. All right, grams of H2O. Now what you do is you go find your conversion factor that talks about grams. The only conversion factor that talks about grams is the one with molar mass down here. And it says 1 mole of H2O is 18.015 grams of H2O. So we take that 18.015 that goes with grams of H2O and put it up here next to our grams of H2O. This is going to make grams and grams cancel out, which is the goal. Now what goes on top here in this blank is the other side of that conversion factor, this 1 mole of H2O. So 18.015 grams of H2O is equal to 1 mole of H2O. And I'm going to highlight this so that we can follow it. All right. Now we're in moles, but we're trying to get to molecules. So we're going to have to do some more converting. Now whatever's on the top here goes on the bottom next. We know that. So moles of H2O is going to have to go on the bottom next. So we'll put moles of H2O. Now if we go look in our conversion factors, we've got another conversion involving moles of H2O. It's up here. It says 1 mole of H2O equals 6.02 times 10 to the 23rd molecules of H2O. That conversion comes from Avogadro's number. So now what we'll do is we'll put that 1 mole from right here, 1 mole, put it into the chart with moles of H2O, and the thing that it's equal to goes on top. 1 mole of H2O is equal to 6.02 times 10 to the 23rd molecules of H2O. So moles of H2O will cancel out with moles of H2O. We're left with molecules of H2O. And the last thing you have to do, as always, is multiply your top numbers together and divide by each of the bottom numbers. If you do that multiplication and the division, you'll get the answer 9.80 times 10 to the 23rd, and that is molecules of H2O. So we took some grams of water and converted that to molecules of water using Avogadro's number and the molar mass. Let's go look down here at number 2. Number 2 says how many grams of mercury, Hg, are produced by the decomposition of 942 grams of mercury oxide, which is HGO, in the following reaction. So we've got a chemical equation there. Now we approach this problem same way as we always do. Look for the given. The given here is 942 grams of HGO. So that's what I'm going to put in the upper left-hand corner here. 942 grams of HGO. Now, we're starting in grams of H2O, and we're going to try to get to grams of Hg. Now, this is going to follow a much different path than our previous question. And the conversion factors that we're going to use are listed down here. All right, so we're starting with grams of H2O. The only conversion we know, like if you go back up to the top, the only conversion we know that uses grams is this one, grams to moles. So if you're in grams, the only thing you can do is go to moles using the molar mass. And we're going to do that down here. So to go from grams of HGO, mercury oxide, to moles of Hg, we're doing this bottom conversion, which comes from the molar mass, which you could calculate using your average atomic masses from the periodic table. But I went ahead and did it for you for time's sake. So we're going to take that conversion and go from grams HGO into moles of HGO by plugging in. Now whatever is on the top, which is grams, goes on the bottom next. So grams of HGO will cancel out with other grams of HGO. Our conversion factor number there is 216.589 grams of HGO, which is equal to 1 mole of HGO. So now we are in moles of HGO. If you're in moles, you can switch substances, which we need to do because we're trying to get to grams of Hg. So to get from moles of HGO to moles of Hg, we have to use stoichiometry, which uses the numbers from the balanced chemical equation. Like up here, we need down here moles of HGO. So you see how many moles of HGO are in the equation. And that's 2. So you put 2 moles of HGO becomes how many moles of Hg, which is what we're looking for. It becomes 2. So you put 2 moles of Hg up there. Moles of HGO cancels with moles of HGO. Now you're in moles of Hg. Awesome. Last thing to do is we're trying to get to grams. To go from moles to grams, you need the molar mass, which is this middle guy here. 1 mole of mercury equals 200.59 grams of mercury. Whatever was on top goes on bottom next. So I'll put the 1 mole on bottom and the 200.59 on top. Moles and moles cancels. Now you're in grams of mercury, which is what the question asked for. All you gotta do is multiply across the top, divide on the bottom. Type all that into a calculator and you should get something along the lines of 872.42. That is grams of mercury. On this next section, I'm going to do just this top problem for you, and then I'll put the answers for the bottom problem so you can try to do that one on your own and check it. But this time is going to be a little bit more difficult because you're going to have to fill in your own conversion factors. All right, so for this one, we're going grams of O2, starting with grams of O2 over here, 84.1 of them. And we're going to try to get to grams of SO3. So you draw the chart, just like always, and put your given information over here. 84.1 grams of O2. Now, if you're in grams, the only conversion that has grams is molar mass. So you're going to take that grams, use the molar mass to change it to moles. So out of our 3 conversions here, down here, we'll see which one has grams of O2. And it is this bottom one. 1 mole of O2 is some number of grams of O2. And you got to find that via molar mass. Conveniently, there's a nice molar mass chart right there for you to use. O2 has only the element oxygen. It's got 2 atoms of oxygen. The average atomic mass of oxygen is 15.999. You can go look it up on the periodic table if you don't have it memorized. And if you multiply those things, you get 31.998 as the total molar mass of O2. So that's the number that goes right here in my conversion. 1 mole of O2 equals 31.998 grams of O2. And I can go ahead and put that into the chart. We started off in grams of O2, so grams of O2 is going to go on the bottom next. There's 31.998 of them, and that equaled 1 mole, so 1 mole goes on top, 1 mole of O2. Now we're in moles of O2, which is a good opportunity to switch substances into SO3, because we're looking for SO3. So let's see how many moles of O2 equals how many moles of SO3. To find that, we use this top chemical equation right here, and we look at those coefficients. There are 12 moles of O2 that become 8 moles of SO3. So 12 moles of O2 equals 8 moles of SO3. We get to plug that in. Now we're starting with the unit moles of O2 on top, so moles of O2 goes on bottom next, and that is 12 of them from the conversion factor, which equals the 8 moles of SO3 on top, because the 2 things that are equal to each other go on top of each other. Moles of O2 cancels out. Now we're in moles of SO3. We wanted grams of SO3. Now to go from moles to grams, we got to know, you guessed it, the molar mass. We do that by filling out this chart. We've got sulfur and oxygen. There's 1 sulfur, 3 oxygens. I'm trying to remember what sulfur's is. I think it's something like 32. Let's look it up really quick. Let me drag out my periodic table. Let's see, we only need 1 of them. All right, there it is. Sulfur is 32.066. So that's what we're going to put in our average atomic mass for sulfur. 32.066. That is grams. And oxygen is 15.999 grams. Multiply everything out. So your sulfur total is 32.066 grams. And your oxygen total is 47.997 grams. Add those 2 things up and you get let's see, 80.063. So that's the number that's going to go right here. 1 mole of SO3 equals 80.063 grams of SO3. Now we're going to pop that sucker into this last frame of our chart. Right now we're in moles of SO3, so that has to go on bottom next. The conversion factor says 1 mole of SO3 equals 80.063 grams of SO3. Moles of SO3 cancels. Now we're in grams of SO3. Last thing to do is multiply and divide. If you do 84.1 times 1 times 8 times 80.063, and then divide that by 31.998, and also divide it by 12, and also divide it by 1, you'll get 140 grams, and that is of SO3. Now, I know that's a really long process for one of these questions, but you do have to be able to do all of those steps on your own. So go down here with number 4. See if you can figure it out. Pause the video. Try to work your way through it. And then I'm going to write the answers. You can check them when you're done. All right, there's your answers. Go ahead and check through your work. Make sure you've done everything correctly. If you haven't, rewatch the video or email your teacher for help. All right, so the trickiest thing when it comes to combining these conversions is knowing what conversions you really need to use and when you need to use them, because we've now got 3 factors. You don't use every one of them every time. You got to figure out which ones you have to do. So I like to use this chart as a reference to help me, but you will not get it on your test, so you've got to memorize it or just know how it works. But this is a mapping for all of the different conversions you can make. So how you use it is you find the thing you're starting with. Okay, let's look at this one down here as an example. Let's see, this one down here, number 1, is how many grams of H2O3 are produced in a reaction that uses 1.89 times 10 to the 24th molecules of Si2H3. So we're starting with this unit and substance, 1.89 times 10 to the 24th molecules of Si2H3. So we're starting up here in the molecules part, okay? That's where we are currently. At the beginning, we've got 1.89 times 10 to the 24th molecules of Si2H3. That's what we've got. Now we need to see where we are headed. And the question asks how many grams of H2O3 are produced. So we're going to put that up here with the grams. So we're trying to get to this. This is our question mark. No, you don't need to write this down every time. I'm just showing you how the chart works. So we need to get from here with molecules and atoms to here with grams. And that grams is going to be of the substance H2O3. All right, so along the way, we do have to switch substances because we don't start and end in the same substance, and we've got to get from molecules to atoms. So the path we're going to have to take is we're going to start with molecules, and we're going to go to moles because that's the only thing you can do. And then we can either switch substances or we can go straight to grams. But we do have to switch substances because we're not in the correct substance to begin with. So we're going to go from molecules to moles. Then we're going to switch substances. So we'll end up back in moles, but moles of a new thing. And then we're going to go from that moles to grams. That's going to be our map of things that we do. So we're going molecules to moles. Then we're switching substances. Then we're going to grams. That's the possible path that we have. So let's go look at how that works down here with number 1. So number 1, we said we're starting with, and I'm going to fill in this chart down here. You really don't need to do this chart every time. I'm just trying to show multiple representations of how to think through this. So we're starting with molecules we said molecules of Si2H3, and we're going to try to get to grams of H2O3. So I'm going to be filling in this top chart as we go as well. I'm going to go ahead and put that 1.89 times 10 to the 24th molecules of Si2H3. Sorry, it's hard to fit everything in the box there. And we said from molecules, we're going to go straight to moles, just like that. Molecules to moles. So I'm going to write that down here. We're going to go molecules to moles. And that keeps the substance the same. It's still going to be Si2H3. So whenever you go molecules to moles, that keeps the same substance. All right, so we're going from molecules to moles, keeping the same substance. And the way you go from molecules to moles is the conversion factor that 1 mole of the thing, Si2H3, equals 6.02 times 10 to the 23rd molecules of that thing. I'm going to go ahead and plug that conversion factor into my chart. So we're starting off with molecules on top. That means we're going to put molecules on bottom next. So we'll have 6.02 times 10 to the 23rd molecules of Si2H3. And that's equal to 1 mole of Si2H3. Now the next thing we said we were going to do is we're going to do a substance switch because we've got to get into this new substance, H2O3. In order to switch, we're going to use the mole ratio and the chemical reaction. All right, so the chemical reaction is listed up here for your viewing pleasure, and it's going to tell us how many moles of each thing there are. So I'm going to go ahead and write down here in the chart that we're going from moles of one substance to moles of a new substance, so H2O3. Now the conversion factor that gets used there is some number of moles of Si2H3. So we go look at that in the chemical equation. There's 4 of them. So you say 4 moles of Si2H3 equal how many moles of H2O3? And that is 6. 6 moles of H2O3. Awesome. And now we're going to plug that into the chart. We've got moles of Si2H3 on top, so it's got to go on bottom next. There's 4 of them. 4 moles of Si2H3 equals 6 moles of H2O3. And now we're in moles of H2O3. We're trying to get to grams of that. So in order to go from moles to grams, just like we said we were going to do in our chart here, to go from moles to grams, you have to use the molar mass of Si2H3. So we're going to have to find that molar mass. Oops, that was the wrong color arrow. We'll say 1 mole of H2O3. Sorry, did I say Si2H3? We're finding the molar mass of H2O3, which we already found above to be 50.013. 1 mole of H2O3 is 50.013 grams of H2O3. And we get to plug that into the chart. Started in moles of H2O3, so that goes on bottom next. 1 mole of H2O3 equals 50.013 grams H2O3. And then you multiply everything across the top, divide everything on the bottom. Remember, if you're dividing by 6.02 times 10 to the 23rd, you got to put that sucker in parentheses. Super important. All right, so that is how you combine all of these conversion factors together. There's 3 of them. I do heavily recommend using the chart, at least when you're starting, to kind of map out what you're going to try to do before you just start throwing conversions at the chart, because sometimes that's going to get you somewhere you don't need to go, and you'll spend a long time doing work you don't need to do. So hopefully this helps you out while combining conversions. We've got one more topic left in this unit, and that is going to be limiting reactant. That's going to be coming at you tomorrow, and it is going to use these conversions. So make sure you know how to do them, and make sure you know how to put them together. As always, please contact your teacher if you need some help. You can always rewatch these videos to get more help. But please let us know if you're struggling.